Artemis I is paving the way for us to explore deeper and deeper into space.
I think Artemis I is significant on so many levels. It is a new frontier to do science.
So the primary objective is to test the Orion spacecraft integrated with a space launch system.
And it is designed to carry out the boldest of the bold missions.
But it's more than just learning how to travel in space. We're taking a lot of cool science along with us on this first mission to the moon.
So as NASA plans to go back to the surface of the moon and then onto Mars,
we want to spend more time there, and that's riskier business. So the more we learn about the moon itself and the environment where we'll be operating, the better we can prepare. We have 10 CubeSats we call secondary payloads, which are small scientific spacecraft of their own that will each be conducting their own scientific mission.
All of these payloads in some form or fashion will help us going forward. They are going to be studying the moon.
And they're going to help us understand what is the moon made out of, what types of rocks, what types of regolith, what types of ice, what's mixed in with water that might be present.
One of them actually is going to attempt to land on the moon. They're going to be studying the sun.
Understanding and studying the space environment or the space weather.
Some different propulsion systems. These novel ideas will ultimately turn into the technology and the systems that we want to use going forward.
There's a lot of cool things going on between all these CubeSats that make up our secondary payloads. Additionally, inside the Orion, we'll be flying an experiment to study space biology.
Space biology is where we study the underlying changes that Earth-based biological systems undergo when they're in space.
Or basically, how does life respond to the space environment?
The level of ionizing radiation that you experience when you go beyond the Van Allen belt, so you go beyond the protective magnetic sphere that we have around us, you then get exposed to higher levels of ionizing radiation. So we are flying several space biology experiments.
We will take a series of materials,
plant seeds, fungi, the yeast cell, algae,
and ride along the trip. And then when it comes home, we can analyze how they responded to that environment.
This research will help us thrive in space. It will help us to go further and stay there longer.
In addition to space biology, we'll be learning about how to make astronauts more effective in the Orion in the future. An example of that is something called the Callisto Technology Demonstration.
Lockheed Martin built the Orion spacecraft for NASA, and we'll be flying a secondary payload that's a demonstration payload called Callisto. So we took the technology from Amazon for Alexa and the WebEx technology from Cisco, and so we built a digital assistant, if you will, a custom space-qualified Alexa.
Alexa, how does the life support system work?
Orion's life support system is the environmental control and life support system oracles.
And so this payload is the demonstration mission to show how astronauts in the future could use this technology as an innovative user interface.
So there you have it. I hope you agree with me. This is exciting.
I am just over the moon excited for the Artemis I launch.
The science we'll conduct on Artemis I lays the groundwork to ensure that we can safely conduct scientific activities at the moon with our astronauts going forward. This really is the stepping stone for us as we take that next giant leap in space exploration.